Hello students, welcome to BioSmart Academy. In today's lecture, we will continue our lecture series on isoelectric point. Okay. So first of all, I want to explain you that, or I want to say you that we already completed two lectures on isoelectric point. Okay. In our first lecture, we basically seen about the basics of isoelectric point. Okay. And in our second lecture, we see how to calculate isoelectric point for non-polar, or you can say for non-ionizable amino acid, for non-polar or for non-polar and for non-ionizable amino acids. Okay, so these two lectures were already completed, that is basics of isoelectric point and calculation of isoelectric point for non-polar as well as for non-ionizable amino acids. Okay, so I hope that you watch these two lectures, and please, before watch this lecture, please go and watch first these two lectures, because these are the basics lecture to understand today's lecture. Okay, so now let's start today's lecture, that is isoelectric point. And in today's lecture we will discuss, this is the part 3 of the lecture of the isoelectric point. First of all, okay, part 3. And second important point is that in today's lecture we will see how to calculate this isoelectric point, how to calculate this pi or isoelectric point for ionizable amino acids. Okay, clear now? So let's start today's lecture. Okay, so first of all, before I start today's lecture, you have to know that which amino acids are ionizable in nature, Okay, so first of all I just want to recommend you that please take a copy and pen and please write down all these things that I discuss here. Okay, note down all that things that I discuss here. Okay, so first of all you should know that which amino acids are ionizable in nature. Okay, so we all know that there are 20 amino acids. Okay, and out of these 20 amino acids, there are 7 amino acids which are basically ionizable in nature. There are 7 amino acids which are basically ionizable in nature. Clear? So which are those 7 amino acids that are ionizable? Okay, and this ionizable group are actually basically their side chains. Okay, Okay, so first of all you should know that which are the amino acids that are basically ionizable in nature. Okay, see, so I already mentioned that there are 7 amino acids that are ionizable in nature. Okay, so the ionizable amino acids are, the ionizable side chains, amino acids are as follows. Okay, so this is represented as pKr. Okay, this is represented as pKr, ionizable side chains. Okay, so the amino acid are, first of all, basic amino acid, second acidic amino acid, and the third is, apart from basic and acidic, cytosine and tyrosine. Okay, C for cytosine, and the single letter word for tyrosine is Y. Okay, Y. And the acidic amino acid are aspartic acid, that is D, and glutamic acid, that is E. Clear? Okay. And the basic amino acids are histidine, this is actually, you can say buffer, or you can say just basic, lysine, that is K, and arginine, that is R. So these 7 amino acids, 2 plus 2 plus 3, these 7 amino acids are having their ionizable side chains, and this ionizable side chains represented as pKr. Okay, represented as pKr. Clear? Now another important thing is that what do you mean by this ionizable side chains? This ionizable side chain means, suppose this is RH, it can ionize into R minus plus H plus. So this is basically ionizable. Okay, ionizable side chains. Okay, clear? Okay, next. Now, till now we calculate isoelectric point for non-polar and for non-ionizable side chains as pk by using the pk1 value, by using the pk2 value. Okay, we use only these two. Okay, and in today's lecture, as we are going to see the isoelectric point for ionizable side chains, so we have to use another pk value, that is pkr, as I already mentioned. Okay, so you know that pk1 value is constant, we take as 2 as an average value. Okay, and above 2, that is if we go 3 4 5 3 4 5 up to 14, that is above 2, it become what? From CO minus COH to CO minus. I already discussed all these things. Okay, when you go above 2, that is from 3 to 14, the COH, that is H, is basically removed and it become deprotonated and becomes CO minus. Okay, and when we go below 2, that is from 0 1 2, among these three, CO minus is converted into COH, or you can say actually at pH 1 the amino acid is in COH form, so it will remain as COOH form. Okay, so this is on pK1. So we take the value pK1 for 2, we take the pK2 value as 9. Similar way, if we go above 9, then the NH3 plus charge become neutral, and if we go below 9, then it will remain as NH3 plus. Clear? So these two value will remain in today's lecture as well. Apart from this, I already discussed that pKr value will be included for all those 7 amino acid that I discussed. Okay, and another important thing, please note it down. You have to learn the pKr values for all those 7 amino acids. Okay, it may be possible that you don't get the pKr value on examination, so you have to learn this. Okay, clear? Now, so how can you learn this? You have to learn by using some trick. Okay, see, one trick I basically provide you. See, as I already told you that acidic amino acids are basically having ionizable side chain, that is aspartic acid is D and glutamic acid is E. So pKr value for aspartic as well as for glutamic acid taken as 4. Okay, as they are acid, so they will be below 7. So this is one trick, and as an average, or you can say as an approx, we can take 4 for both glutamic acid and for both glutamic as well as aspartic acid. pKr value we can take as 4. Okay, because the pKr value for actually glutamic acid is 4.25, which is approx 4, and pKr value for aspartic acid is 3.65, which is also approx 4. So we can take 4 as a pKr value for both glutamic acid as well as for aspartic acid. Clear? Now I hope that you got it. Okay, now for basic amino acid, okay, histidine. We all know that histidine is close to buffer, so its pKr value taken as 6. Very easy to remember. Arginine and lysine. Okay, and lysine. Clear? So what will be the pKr value for arginine? We know that arginine and lysine are basic amino acid. Okay, so remember, it means what? Their pKr value must be above 7. So remember one thing, arginine is the most basic amino acid, so its pKr value taken as approx 12. Remember this, highest pKr value is of arginine, approx 12, and lysine pKr value is 10, approx 10. Okay, clear? So now I hope that you can easily remember the pKr value for both acidic as well as for both basic for this 5 amino acid. Okay, now how can you remember the pKr value for cysteine and tyrosine? The pKr value for tyrosine, you have to remember these two. Actually you can combine. The pKr value for tyrosine is also 10 and the pKr value for lysine is also 10. lysine is with K. Okay, the lysine is K. Okay, so is also 10. So you can combine here the tyrosine Y and K, that is both taken as 10 YK. Okay, 10 tyrosine and lysine. Okay, and the pKr value for cysteine is taken as 8. So this is a unique. Okay, so in this way you have to remember the pKr values. Okay, and you have to remember it. Okay, so these are all important things that I have to discuss with you all before starting the calculation part. Okay, now let's calculate how to calculate the pKr value for both for the ionizable side chain. Okay, I will explain you. Okay, I will explain. Okay, so first of all we take an example. Okay, first of all we take an amino acid, that is glutamic acid. Okay, we take the acidic amino acid. Okay, so for that we know that we have to follow this rule. Okay, that is at pH 1 we have to arrange according to pH 1, then we go for pK 1, as pK 1 value is 2, then we have to add pKr. Why pKr? Because pKr is there in case of ionizable side chain. And why we add pKr first then pK2? Because the pKr value for glutamic acid we discuss now, as we discussed earlier, 4. That's why pH 1 means 1 pH, pK 1 pH is 2, so that's why we arrange according to this 1 2, then like this. Then pKr value for glutamic acid is 4, so it will become, then pK2 value is 9, so it will come later, and then at 14, and then at 14. Okay, then at 14. So in this way we have to calculate. Okay, so first pH 1, then pK 1, then pKr, then pK2, then 14. Okay, we arrange all these according to pH. Clear? You have to arrange according to pH. Okay, and we all know that for glutamic acid the pKr value is 4, that's why we arrange. Okay, the pK2 value is 9, we all know that the pK1 value is 2, and this is pH 1, this is pH 14. Clear? Now let's look how to calculate the pi for glutamic acid. Okay, I will explain very clearly. Okay, so please note it down. So first of all you should note the structure. This is a structure of the glutamic acid, and remember this structure is at pH 1. We will start from pH 1. Okay, this structure at pH 1. Clear? This structure is at pH 1. Okay, CH2 CH2 and COH. So this is at pH 1. Okay, clear? Now when we move, so this is a structure of glutamic acid, this is a side chain. Okay, this is a side chain. Okay, clear? This is a side chain, very easy. And in case of aspartic acid, one CH2 is removed, only single CH2 is present. Okay, so this is a structure at pH 1. Now when we move from pH 1 to pK 1, okay, so what is the value at pK 1? That is 2. So at 2 it will remain as it is COH, it will also remain as it is COH, and this will only remain as it is, that is plus charge. Okay, so at so when we move from pH 1 to pK 1, the charge will remain plus 1. Okay, the charge will become plus 1. Why plus 1? Because at pK 1 the value is 2, so it will remain as it is COH, because when you move above 2 then it will become CO minus. Okay, it will also remain as it is COH, and this will also remain as it is NH3 plus. Okay, because when we move above 9 then it will become neutral. Okay, so there is only one charge we can see, that is plus, that is plus 1. Clear? Now when we move from pK1 to pKr, okay, pKr, so you all know that pKr value is what? 4. So when we move from pK1 to pKr, this COH becomes CO minus. CO minus because above 2, and above 2 means what? It will have to lose this H plus, that is proton, and it became deprotonated, that is CO minus. Okay, so when we move from pK1 to pKr, this becomes CO minus. This remain as it is COH. Why? Because its pKr value is what? 4. So at 4 it will remain as it is. When we move above 4, then it will become CO minus. It will lose it H plus. Clear? It will lose its H plus. Clear? And it will remain as it is as it become neutral when we move above 9. Clear? So what is the charge? So the charge here we can see easily -1, and here charge is +1. So plus minus, that is plus 1. So plus minus, that is charge become 0. Clear? So when we move from pk1 to pkr, the charge becomes 0. It means what? It means that this point is the isoelectric point, that is pi. Clear? Why? Because as per the definition, as I already discussed in lecture 1 of isoelectric point, that isoelectric point is the point where the charge becomes neutral, that is -1 and +1. So overall charge becomes 0. So this is the isoelectric point. Okay. So to calculate isoelectric point for acidic ionizable side chain, okay, this is acidic part. For acidic ionizable side chain is pk1 plus pkr by 2. Okay, I will write the formula after completing this. Okay, now move next. Now when we move from pkr to pk2, what happened? So you know that pk2 value is 9. So it will remain as COO minus because above 2. Okay. Now this COH now becomes COO minus. Why this COO minus? Because it will become above 4, that is 9. So it will also become CO minus, and it will remain as it is +1 because its charge is 9, its value is 9. So it affected only when we move above 9. So it will remain as +1. So from pk to pk2, what is the charge? So here is -1 and here is -1 and here is +1. So what is the charge when we move from pkr to pk2? So charge become -1. Clear? Now last part. When we move from pk2 to pk14, what happened? What will be the charge? So when we move from pk2 to pk14, the charge become what? This will remain as CO minus, as it is. What will be the charge? So this will remain as CO minus as it is above 2. This will also remain as CO minus at it will also above 4 as it is. We calculate at pH 14, and this become neutral, that is here charge becomes 0, that is become NH2. It become NH2. Okay, clear? Neutral. Okay, so charge become what? -1 and -1. So what will be the charge? That is -2. Okay, so in this way you can calculate the charge from pH1 to pK1, from pK1 to pKr, from pKr to pK2, and from pK2 to pH 14. So in this way you can calculate each and every for each and every pH, pK, you can calculate the charge very easily. So it is very easy concept, you can understood it very clearly. Okay, very important. Okay, so I hope you don't get any confusion here, and if you still got any problem, then please comment on the comment box. Okay, now write down the formula for isoelectric point. Here we can see that the point where the charge become neutral, that is from pk1 to pkr, is the isoelectric point for acidic amino acid. Okay, so for acidic amino acid, isoelectric point can be calculated as pk1 plus pkr by 2. pk1 plus pkr by 2. So we can take pk1 as average 2, pkr for glutamic acid we can take as an average 4, and we can take it is 2, that is 6 by 2, that is become 3. So in this way you can calculate the pi for acidic amino acid ionizable side chain. Okay, clear? So I clear each and everything. I clear you that how you calculate charge at each and every moment from pH1 to pK1, from pK1 to pKr, from pKr to pK2, from pK2 to pH 14. And also I also write down here the formula. So if you don't forget, if you forget that, then you can directly use this formula so that you can calculate it. Okay, now your task is what? You have to calculate the charge for aspartic acid, and if you calculate it, then please comment on the comment box. Okay, now let's look how to calculate charge for basic amino acid, that is for basic ionizable side chain amino acid. Okay, let's look. Okay, so same way we use the same trick, that is we have to take pH 1 to pH1 to pK1. Okay, as we were going to take the example of histidine, as I already mentioned you that the pKr value for histidine is 6. It means what? It is less than pK2 value. That is, we know that pK2 value is 9. So we have to put first pKr value as we take the example of histidine. Okay, pK2 and the last is 14. So we arrange according to pH. Okay, according to pH. So it is at pH 1, it is at 2, pK1 value is 2, its pKr value for histidine is 6, and for pK2 value for pK2 value is also common, that is 9, and this is pH 14. So we arrange according to sequentially. Okay, sequentially we arranged. Now, so there are 3 basic amino acids we know: lysine, arginine, and histidine. So lysine and arginine structure is very simple, so it can easily calculated. I take the example of histidine because many students got confusion on histidine because the structure for histidine is very complicated. Okay, so that's why I take the example of histidine. Okay, so your task will be calculate the pi value for lysine and arginine. Okay, now let's look at the first. You have to look at the structure. Okay, then we will go for the calculation part. See, this is a structure of histidine. This is CH2 value and histidine contain a ring. Okay, NH, this is CH. Okay, this is NH. Okay, just write it here like this, NH plus. Okay, and it double bond. Okay, double bond. Okay, and it is CH. Okay, and this. Clear? So this is a side chain. Okay, very complicated structure, but you have to remember. You have to remember all this. Okay, H. Okay, so this is a side chain. Okay, this is a side chain. Clear? And what is the value for this side chain? pKr value is 6. Oh, I'm sorry, I'm really sorry. I have to write down all these things. Okay, I will write down all these things quite fast. pK1, then pKr, as we take the example of histidine, then pK2, then pH 14. Clear? Now just look at the structure of histidine very fast. This is a structure of histidine. Just look at the structure. Okay, now okay, so this is the structure of histidine. Okay, and this is a side chain, as I already mentioned you. This is a side chain of histidine. Okay, and its pKr value is what? Its pKr value is 6. Clear? Okay, and this is a pK1 value, as you all know that, and this is a pK2 value, as you all know that. Okay, so now let's look. So remember, first point is that this structure is at pH 1. Okay, clear? Now when we move from pH 1 to pK1, what will happen? When we move from pH 1 to pK1, what will happen? See, we all know that pK1 value is what? pK1 value is 2. So when we move from pH 1 to pK1, this will remain as COOH. Nothing will be changed, because above 2 it will become COO minus, that is become deprotonated. Clear? And below 2 and 2 and on 2 it will remain as 2. Clear? It will remain as protonated form, that is COOH. Okay, it will also have an it will also not going to affect. Okay, it will remain as it is, plus charge, and it will also remain as it is, plus charge, because its pKr value is 6. So above 6 this charge will be affected. Okay, so what is the total charge when we move from pH1 to pK1? Here is a charge plus 1 and here is a charge plus 1. Look at this side chain. So, okay, so there is plus 1 plus 1, that is 2. So that is plus 2. So charge is plus 2. Clear? Now when we move from pK1 to pKr, we all know that pKr value for histidine is 6. So what will happen? So when we move from pK1 to pKr, this COOH becomes COO minus. Why COH becomes COO minus? Why it becomes deprotonated? As I already mentioned repeatedly, that it is above 2, that is 6, that why it become deprotonated. Above 2 means deprotonated, so it becomes CO minus. It will remain as it is, plus 1. There will be no effect on this NH3, because for this you have to move above 9, so it will remain as it is, plus 1, and it will, and the side chain, that is ionizable side chain, is also remain as it is, that is plus 1, because it is on 6. So what will be the total charge? That is plus 1 and minus 1. So total charge when we move from pK1 to pKr will be what? Plus 1. Clear? Next, when we move from pKr to pK2, what will happen? So when we move from pKr to pK2, so we all know that pK2 value is what? 9. So this will remain CO minus, because above 2, so this will remain as it is, that is minus 1 charge. Clear? Now this ionizable side chain, it has pKr value 6, and we move from pKr to pK2, that is 9, so this will become above 6. So here the charge become neutral, that is it become N. From NH plus it loses its proton and remain only as N, so charge become is what? Here the charge become neutral, that is N. Okay, so it become neutral because at 9 and its pKr value is 6, so deprotonated occur and its charge become neutral, that is N. Clear? And this will remain as it is, plus 1 for NH3, because its pKr value is, its pK2 value is 9, and we look at 9, so that's why it is remain as plus 1. It will not affected, it will affected only on pH 14. Clear? So here the charge is plus 1 for this value, okay, and minus 1 for this, okay, because it is become neutral, so plus 1 minus 1, charge becomes 0. So for basic amino acid, ionizable side chain, the formula is pKr plus pK2. Clear? Because this point is the pi point, or you can say isoelectric point, because here the charge become neutral. Okay, now when we move from pK2 to 14, what will happen? So when we move from pK2 to 14, what will happen? So when we move from pK2 to 14, this will remain as minus 1, this will remain neutral, and this will remain as neutral, so the charge will minus 1. Why? Because only this charge remain, CO minus, because this is also become neutral, because above 9, that is 14, and this is also become neutral above 6, that is 14, and this is become COH to CO minus, because above 2, that is 14, so charge only remain as minus 1. So I hope that you got the clear idea, okay, about this. If you still have any doubt, then you may comment on the comment box. Okay, now write down the formula. So for basic amino acid ionizable side chains, the pi can be calculated as pKr plus pK2 by 2. So pKr value is what? For histidine 6, pK2 value we take as 9 by 2, that is 15 by 2, that is you can say approx 7.5. So for histidine the pi value is approx 7.5. So this is a concept. Now guys, I want to give you a task. You have to complete the calculation part for the lysine and arginine as well. If you complete it, you can complete. If you can complete, then you may comment on the comment box. I hope you like today's lecture, and I hope I can make your confusion clear. Okay, I can make your confusion clear for today's lecture. Okay, so that's it for today's lecture. If you have any doubt regarding all these things, regarding calculation for isoelectric point for any amino acid, then you may comment on the comment box. You may comment me on the comment box. I will try to solve your doubt. Okay, so if you have any doubt regarding the calculation for amino acid, you may comment me on the comment box. I will try to clear your doubt. Okay, so that's it for today's lecture. I hope that you like today's lecture. Okay, so we will meet on our next lecture. Okay, till then, thank you. Stay safe, stay happy, and stay healthy.